Hello, welcome back to my bench. My name's Dave. If this is your first time, welcome. I generally do repairs on pretty much mostly on broadcast equipment, that kind of stuff. But today I've got something different. I got sent a piece of equipment to check out from Banggood. Banggood has sent this to me free, full disclosure, to give a review on it and see what I think. So I'm going to do that. I told them I would be honest, and I will be. But we must understand that this kind of equipment that I have here, this is not a $5,000 meter. This is a $100 meter or less. So we're going to review it as that, not as a big fancy one, but as what it is and coming out today. You got to admit, the stuff you can get today does an awful lot of stuff for not a whole lot of money. Anyhow, what is this? This is Gochifix, I guess. Gochifix. It's an oscilloscope, multimeter, and a waveform generator, all three in one. It's not very big. You can see it's about 7 inches in the box. It says to avoid electrical shock. Yeah. And this one is the 12 megahertz version. If you can see that, 12 megahertz as far as the scope goes. On the back, we've got some ratings for it. We'll get into these a little more later into the video here, but this is a 6,000 count meter. DC voltage is 60 millivolts to 1,000 volts. 7.75%, plus 10 digits, it says. And they call it uncertainty. AC voltage, 60 millivolts to 750 volts. DC current, 600 microamps to 10 amps total. That's in 2 different ranges on the front. We'll look at that also. Resistance, 600 to 60 mega ohms. Capacitance, it also reads capacitors, 10 nanofarads to 100 millifarads, which would be a lot. That's, 100,000 microfarads? Okay, frequency, the frequency range, I guess, 5 hertz to 100 kilohertz. And it says merge voltage shift 5 hertz to 10 megahertz. Diode testing is open circuit, is about 3 volts. Judging resistance, the on-off test, in other words, continuity test, less than 50 ohms for the buzzer to go off. It has fuses. It has a 500 milliamp at 250 and a 10 amp at 250. Bandwidth, AC and DC to 12 megahertz. And the output, this has a frequency output, little function generator, square wave, triangle wave, and sine wave. So, all that in one little box, one little meter. Let's open it up and see what we got. Well, papers. We got papers. Okay. This is simple operating instruction diagram. Oscilloscope operation and signal source operation. So, anything that's not the meter. And the multimeter operations down here with how the meter switch works and what all the different things do. All right, we'll go through this stuff when we open up. That's pretty dry. And we also have an oscilloscope multimeter manual. So we got like 33 pages of manual. Wow, that's interesting. Oh, main features. It says that the scope is 50 megasamples high speed per second, high speed sampling at 12 megahertz. Signal source outputs 3 types. We saw that signal source output frequency, duty cycle, fixed point, and adjustable. Well, that's interesting. That means that it'll you can set the frequency or the duty cycle of the output also in square wave, I suppose. That's pretty cool. I mean, that can come in useful. Configured with replaceable 18650 lithium batteries. Okay. Data waveform hold function, and it holds 100 sets of data and 10 waveforms can be stored internally. Relative, yeah, it has, okay, so it has relative for zeroing the meter out. Meter functions includes voltage, currents, resistance, capacitance, frequency, duty cycle, diode on-off testing, and automatic. 15, okay, it'll go off after 15 minutes. All right, well, this is, enough of that. Let's take a look at it. What we got here? All right, we got probes. Standard, I'm sure. Ow, but they are sharp. I'm sure these are not going to be, well, they're not terrible. They're not those real stiff, awful ones. They're actually quite flexible. They're not silicone. They're just regular, but pretty decent quality ones. They're not $1,000 or 1,000 volt probes, that's for sure. What do they say on them? They say 1,000 volts to 10 amps. No, they're not. These would be line level max, I think, would be about it. Okay, and they're removable little caps. Those are nice, and they do have the little catches so that you can put on things like alligator clips that go in the front of them, and they are about that long. Meter, not a meter. Yeah, about. Okay. Not bad. Kind of happy with that. Also comes with a charging cable, because this is rechargeable. We'll look and see how long it works on a charge, too. All right. That's everything in the box. All right. That's all the dry stuff. Let's open up the meter here. Nice little bag. Strong little bag. Wow. Okay. And first look, comes in a plastic bag of its own. Bag in a bag in a bag in a bag. Okay. And there it is. All right. First impressions. It's not heavy, but it's also not extremely light. Does have little sort of rubber baby buggy bumpers around the edge of it. And that's pretty good. It don't twist. It's solid. It's solid. Got to give them that. I mean, that's pretty good. The bail, ooh, it's stiff. Well, probably, wow. But that's a good thing. Because you want it to stay where it goes. And yes, it'll slide. It doesn't have anything on here, to keep it from moving. But it's not terrible. I mean, if you hold your finger on the top, you can push them. But it's going to walk away from you a little bit if you try to do that. But everything does that. Okay, on the front we got our F1 through F4 and our auto and that kind of stuff. On, off. Okay. Auto power on. And it comes up in voltage. Well, first button here. And I don't know. I'm thinking about that. I mean, it tells you, it came charged too, by the way. It says it's in auto, and it's on 600 volts range. It's in voltage, and down here it's got rel for relative, which would be these F1, pH, that's hold, I presume, peak hold, yeah. Yep, peak hold, run, stop, exit, and reset. Oh, that's kind of nice. Okay. Select. All right. Oh, okay. That's how you get to AC, millivolts, and hertz. Okay. And percent, frequency percent. Interesting. And back to DC millivolts, 600 millivolts. And range, all right, so you can set the range here and have it fixed. RNG range. Cool. All right, so basically everything. Do we get back to auto? Yep, one button goes back to auto. I like that. I got a meter that I have never figured out how to get it back to auto again. You have to turn it off and turn it back on. All right, so let's see. What's got millivolt range. Select millivolts, AC millivolts, and DC millivolts. And it 60. It's on auto to 60. And then you got resistance. Automatically goes into resistance for 60 ohms. Select, we got the auto for diode, continuity, and resistance again. CX, that's just, I'm sure, for capacitance. Hertz. Okay, so we got hertz and we have a selection. Select means frequency or percentage. Oh, okay. All right, so it's frequency or percentage of duty cycle, I guess. What's next? Microamps, DC, and AC, of course. Yep. And of course you can set the range. Milliamps, same thing. Yep, set the range. And DC and AC, 10 amps, and off. All right. Let us make some measurements here and see how it does. Let me get some stuff ready and I'll be right back. Okay, well, I got my little cheap voltage source here. We're going to turn this guy on and we're going to do some voltage measurements first. We're on DC voltage, which is what it comes right up to. And short amount. Okay. And which one's plus? Here we go. All right, let's see. We are on the 2.5 volt scale. It says 2.499. Yeah, that's pretty close to 2.5 volts. This thing is pretty accurate. I got to give it that. All right, let's go to the 5 volt scale and see how it is there. 5 volt scale, 4.996. Yeah, that's close enough for me. Let's go up here. Now, since this is a 6,000 count, that means that since I'm on 7.5, this should switch ranges. And it did. And we got 7.5 volts. Very accurate. Good enough for me. And now we'll go to 10. And it's 9.98. All right. Okay. Let's do some AC. How am I going to do AC? Hang on. All right. I think I figured this out. Let's bring up the function generator. All right. My function generator is set at 60 hertz, 3 volts right now. And I got it coming out this piece of cable. Let's see, put this in here. Nice, it fits. Nice job, guys. That's kind of important. We'll do that, and we'll put this on select AC voltage. We're looking at 0.957. 0.957. So what would that be? 3 volts is approximately 1 volt. So let's see. Do the math just because we can. So we got 3 divided by 2 equals 1.5 times 0.707 approximately equals 1.0605. plus drops in the cable, stuff like that. Yes, we have 0.957. Let's take this up to 5 volts. Let's see what we get here. 5 volts, so it'd be 2.5. I can do that in my head. 2.5 times 0.707 equals 1.75. Okay, 1.608. So we are, including the drop of the stuff here, we're doing it, we're reading what we should read. However, I wonder how far this thing will go. Let's take the frequency up, because right now I'm at 60. Let's add a 0. Let's make it 600. Still at 5 volts. Yep, 1.606. Let's try 6,000. New. Nope, it won't do that, and I didn't expect it to. How about 1,000? Yep, 1 kilohertz. It'll read AC voltage at 1 kilohertz. All right, so I would say basically this meter is good to about 1 kilohertz AC for reading AC voltage. But let's look at, we want frequency. We're looking at 999 hertz or 1 kilohertz, and that is correct. Let's take this up to 5 kilohertz. See how that does. Yep, 4.999. That's excellent. 9 kilohertz. Whoops. That's not kilohertz. That's 9 something. I don't know. Okay. 9 kilohertz. 8.999. 10 kilohertz. 9.99. Let's jump right straight to 20. 19.99, 30, 29.99. Let's go straight to 50. That's not 50. There. 50 kilohertz. No. Okay, it'll read 30 kilohertz. 35. No, it won't read 35. So approximately 30 kilohertz, where it drops off. Good enough for this kind of meter. We're not, this isn't a frequency counter, guys. That's fine. That's doing a good job. Let's see. And it's a sine wave, so that is correct. Let's take it over to a square wave. And I am reading right now 50%. Let's take this to 30%. Yep, 30%. Duty cycle, that is correct. Will it read down to 10? Whoops, well, you got to actually do it, David. Will it do down to 10%? Yeah, 10.1%. So I'd say probably 10% and above is good. And it says that it's 1.8 volts DC coming out of my little generator here. I don't know. Hang on. Okay, I got it plugged into my meter, my Vici meter that I use for everything, and I know it's accurate. 1.8 volts DC. So it is reading the DC element on the AC itself. Yes. Very good. Very good. So far, I'm kind of impressed with this little guy. The battery has not dropped off even 1 dot yet, and we've been fooling around for a while. What else are we going to do? Millivolts. I haven't really got anything to test millivolts that well. Yeah, it says overload on that. Let's take this back up to a sine wave. Make this 1 volt and 1,000 hertz. Okay. And we don't care. It says 9 volts. And millivolts AC, 328 millivolts of AC. That would be, what am I at? 1 volt, yes. 1 divided by 2 times 0.707 equals 353. 353 plus leads and stuff. So yes. Okay. We got her all set up now for some resistance measurements. And let's see what we got here. I've got the meter set up on resistance. Let's measure this. It is 1.794 kilo ohms. Yeah, 1.795K. What does this guy say? It says 1.795K. Well, that's accurate. And this one says 1.033 mega ohms. 1.032 mega ohms. Let's see what this reads on the meter on the screen. 1.033 whatever. Close enough. That's accurate. All right, so the resistance works. I figured it would. Now, let's see. What else we got here? This is my diode. Diode. Hang on, I got to get a diode. Okay, I'm back. Got some diodes. I got big old power diodes here, some that would be considered small power diodes. So, and here. Yes, it does too. Okay, it's reading 0.577 volts. 0.577 volts. Let's check it with this meter. Keep checking with this meter because I know this thing's accurate. All right. And we're reading 0.532. So that's off just a little bit, but it also depends on what voltage you're putting through them. So I'm going to call that accurate. That's good. All right, let's take another one. Oh, let's measure this one backwards just to make sure. And perfect. Okay. All right, now let's go to a germanium diode and test him. I think these are 34s. Oh, this way. The leads are all dirty. 0.382. All right, and this one is going to be a little different because it's different voltage. 0.3107. Okay, so we're going to call that fine too. All right, so it does. Diodes are fine. Let's do some capacitance measurement. That's the one thing that my Vici does not do with a hoot is capacitors. All right, let's go over to capacitor. Oh, wait a minute. We want to test the continuity. We'll find out. Oh, you can barely hear it. It definitely needs a louder beeper than that. I don't know if you can hear that or not. But it's quick. It's very fast. It does have the light. I mean, the light's very accurate and very quick, but it's not nearly loud enough. That should, guys, if you're gonna watch this, make it louder. Good, and it's latched and it's instant. That's good. I mean, I can't fake it. It's right there. That's good. All right. Anything else on here? No. All right. So let's check some capacitors, see what we got. All right. First cap we got here is a 7.5 plus or minus 5%. I would be kind of surprised if this thing would read this. We'll see. It says 0.028 nanofarads. I didn't think it would read that. That's not even fair. Because I can read this. On this one, of course, I can read it. But this is what this does. And it's reading 16 because I got the leads trapped up on each other. I didn't bother to zero it out. Yeah, this one isn't going to read that low. Let's take it up to something it can read. Let's see what it says. This is a 473, 0.047. Yep. 43, yep, 43 nanofarads, 47 nanofarads. That's very good. Let's see what this one says. Forty-five nanofarads approximately. That's good. So let's see how it does on this. This is an audio type Nichicon, 470 microfarads at 50 volts. And we'll just give it time to charge up. It says 471 microfarads, 469. It'll drop 470. Let's try it on this one. 459. Okay, that's fine. And let's go for a big one. This one's 1,000 at 16. All right. Now this one's probably going to take a while to charge up. Come on. 672, 934, 985, 1.2, 1.175, 1.175 millifarads. Okay, which would be 1,000 microfarads. And we're looking at 1.019, 1,010 microfarads. So, yes, it does a fairly good job, and actually pretty quickly, considering that's not its main job. Hertz. We did hertz down below, but I think the hertz for this is higher frequency, which we can still do because my little function generator goes way up. All right, let's. Ready? Here we go. Yeah, 0.999 kilohertz. We are at 1,000 hertz. Let's bring the function generator back up. Let's see. Let's add a 0, make it 10. 9.9 kilohertz. That's cool. Let's just add another one for the heck of it. 199.9 kilohertz. Will it do a megahertz? .999 megahertz at 1 volt. Well, sun gun. What's the select for? Oh, percent. Yeah, it's 50% duty cycle because it's a sine wave. Okay. 0.999. That's good. How about we give this 2 megahertz? 1.999. That's excellent. 5 megahertz. 4.999. Excellent. I wonder if it'll do 6. I think it said 5 on the box. No. Okay, so it is 5 megahertz. All right. I'm not going to go into the amperage on this because I really don't have anything specific to use to do the amperage with. So what we're going to do is the scope portion. Let's put everything back away. And we'll get into the scope portion of this thing. So that's it. I mean, for the meter, that's all we got. Pretty good. I'm impressed. It works well. Accurate, quick, bright, light. I'm even getting used to the numbers. But now we want to go and check out the oscilloscope. So the way you get there, according to the instructions, is you press and hold the auto button for 2 seconds. and there it comes. It's up. So we're going to take our little plug here again, since we can. Plug it into there. And it, whoa. Okay. When it came up, it defaulted to 200 volts. 200 volts. That's quite a bit. I'm feeding 3 volts into it. I'll never see it. So let's take the voltage. It is easy to do. You just hit the button underneath here where it says the F1 through F4. You got time, volts, trigger, and AC, DC. So I'll hit the voltage, and then you got up and down. And there we go. So I got it on 1 volt. Exit, time. There we go. Exit. That works quite well. AC and DC. That's nice. AC and DC. I wish my bench meter would do, or scope would do that. And how's it reading here? Well, it's reading 1 kilohertz. Accurate. That's. Can we get this in a little bit farther, maybe? I don't think it'll help. No, it loses. Someday I'll be able to afford a better camera. So we're reading 1 kilohertz, 937 millivolts RMS, which is correct. That's what we were reading before. And 2.68 volts peak to peak. Okay, so am I losing voltage there? Probably. But that's what it's reading. So that would be correct. So it's reading accurately down there. We're on 500 microseconds at 1 volt scale. And how are we reading on scale-wise? 2.6. How do I move it? That's interesting. Is there a way of moving it? That appears to be a no. This side over here, it's not a touch screen. There's no way to actually move that I can see, at least not in the manual, to move that up and down. That's interesting. Oh well. It does have trigger, and you can adjust the trigger plus for either forward or rise or fall. You can select the mode, which is auto, single, or normal, and then you got level, so you can move your trigger level up and down. The buttons do not, when you hold them, they don't repeat. They're just solid, or just one push each. Okay, so you can adjust that too. That's fine. And exit. And let's see, what else can you do? Oh, you can save it. If you want to save that waveform, you hit the save button, and that just saves it to the current display. And if you want to save it, what's this? Oh, record. Okay. It will record up to 10 of them. I'm not sure how. Okay, so if you want to save a waveform that you've got on the screen, here I've got 1,000 hertz, 900 millivolts, 3 volts input, approximately 2.7. Basically, it's pretty easy. It's a little confusing if you didn't read the book. I actually had the RTFM. So basically what you do is you hit the save button quickly. That also is the stop button. That will stop whatever the input is. It's like a hold for the scope. And then you press and hold the button until it comes up and it says, in this case, record 1. And then you can change that to any of the ones you want. We'll, just for the heck of it, put it in 2. And you hit the save button, and there it is. It's saved in record 2. If I get back here, it's running again. Let's change the time constant a little bit so we can get a different waveform, and change the volts. just a little bit so we can get a bigger waveform. Exit there, so that's all fine. Now I want to save this somewhere else. First you stop it by just pressing the save. Long press to get you into the record numbers. Go to record 1, hit F4 for save, and you're out. Okay? So I'm back to where I was. Well, I'm stopped. You got to go back. You got to hit the save button again. It says up here, triggered, stopped, or single, or whatever it's running. Anyway, that's how you save it. I'm back to just the saved one. And now I can change the time of the... Can I? No. Can I change the volts? No, you cannot. Okay. Kind of useless, actually. If you can't get in and, actually look at the waveform and open it up and play with it, then that's not a very useful feature. We can erase it and go back to live again. Let's see. What else is there? Well, okay. Okay. Well, the little scope appears to work. First thing we got to do, though, is we got to test its frequency ability. Let's see. There's 1,000 hertz. It's reading 1,000 hertz, as you can see. I don't know if you can see that or not, but let's give it 10,000. It's reading 9.98. Time base. Looks pretty clean. Voltage. It's not bad. I mean, there's little globs in my output here, but that's not bad at all. Let's try 5 megahertz or 5 kilohertz. So that's 50 kilohertz. That's pretty good. Okay. Exit time base. 50 kilohertz looks good. And there is 500 kilohertz. Still looks good. Let's go to 5 megahertz. It's reading 5 megahertz. It's a little jumpy. And that is as fast as it'll go, 200 nanoseconds. There's 5 megahertz. That looks okay. And it's still reading, what am I putting in here? 3 volts. I'm on 500 millivolts, so 1, 2, 3, 4, 5, 6. Yep. It's accurate there too. So far I'm kind of impressed a little bit. Now, let's take this thing to where it says 10 megahertz. It's still saying 3 volts peak to peak. It's jumping around a little bit. It's as fast as it'll go on 10 megahertz. Let's go to 12, which is what it says is its maximum. There's 12 megahertz. Yeah. It's still reading 3.1 down here, but it's swaving about just a little bit. But I must admit, it's there. It's reading 11.9, 12 megahertz, 0.85, somewhere around there, 3.1, 3.2 volts, RMS, or peak to peak. My MTech meter, this thing here, it's good to 25 megahertz, and it's accurate all the way up to there. So, just now, let us go and see linearity. Let's go from 100 to, we'll just go 100 to 1 megahertz and do a sweep. Now let's take 10 seconds to do it. And let's see what it looks like. Linear sweep. Well, not bad. It's holding linearity pretty well. Up to 1 megahertz. I mean, all these little artifacts, you expect that in a digital scope, especially one that costs what this does. Tell you what, let's take this to 10 megahertz and see what it does there. We're looking at if it drops off a lot, and it is not. There is 10 megahertz. So, linearity-wise, that is not bad at all. It's working. So the little scope seems to work quite well. You can't, the problems that I see with it are you can't actually save a screen and then go in and expand it out and look for something. If you've got something that's rather hidden or happens only once in a while, or you want to see something in the middle of a given length, you record a microsecond of stuff, and then you want to go in and look at the nanosecond in the middle for something that you're looking for, you can't do that on here, unfortunately. But if you're just looking at waveforms in a guitar amp or a mic processor or something like that, yeah, it works pretty well. I'm actually pretty happy with it. As far as for what it does, I think it works great. I don't have a problem with it. And the fact that it's got AC and DC, yes. Whew. All right. So there's the little scope. Okay. It works. Next thing we've got to try out is the function generator. I'll be back in a minute. Okay, well, so much for all that. Now we got to take a look at the function generator. See how it looks. Most of these things, the function generator isn't worth much. This one appears to have some abilities to it. The way you get to it is when you're in volts here, you hold down this the little button here for about 3 seconds, and it brings you up into your waveform. And you can select your waveform, which is sine wave, square wave, or a ramp. You can set your frequency, and they've got frequencies of 100, 200, 500, 1K, 2K, 5K, 10K, 20K, 50K, and 100K. You don't have variable. You can't do that. So we're just going to leave this at 1K. You can set your duty cycle. We're just going to leave that at 50% at this point. And you can set your voltage. And your voltages go from 0 volts peak to peak, 0.1, 0.2, 0.3, 4, 5, and then 1, 1.52, 2.5, and 3. I wish it had gone to 3.8. That would have given you at least a 0 level output into 600 ohms. That would have been nice. But only a few of us geeks ever worry about that stuff, and we're all on radio and TV. Anyway, so we're going to leave this right now. Let's take this down to 1 volt. So I got 1 volt sine wave, 1 kilohertz, 50% duty cycle, 1 volt, and it's on. You turn it on and off with the auto button. All right, and let's take a look at our scope. There's the scope right there. That's on 500 mils. Let's put on 200 mils. So we're looking, I think maybe I can make this a little bigger for this. Yeah, a little bigger. All right. So basically we're looking at, if we look at the bottom here, 200 millivolts per division. So we're looking at 1 volt peak to peak, 0.336 millivolts, or 341 millivolts RMS at 1 kilohertz. That is not bad. let me put this thing on channel 1. All right. It looks pretty good to me. I mean, that's not a bad sine wave. That's a very nice sine wave. Let's see how far up. I mean, we know it goes up to its 550 kilohertz, but I want to check this. I'm going to plug this into the distortion analyzer and see what kind of distortion this thing has on it. I believe this is set up close to a kilohertz. Yeah, somewhere. Okay, I got the Droid cam going here, and bring it up. All right, we're going to take a look at the distortion analyzer. All right, I just turned this thing on a little while ago, so it's not perfectly accurate yet. But what we're looking at here, if you can see, we are on 1% full scale. Okay. 1% full scale, and we are reading about 0.45%. Now, I don't know if I can get that any better. I'll try. No. That's about it, 0.45. So we're at 0.45% THD, total harmonic distortion. That, ladies and gentlemen, is not bad. For a little device like this, that is not bad at all. I kind of surprised, actually. So let's take this back over to here. Yeah. All right. And bring the scope back up. All right. Now, I just want to check out and make sure what it looks like if we do a different frequency. So let's take this up to 50 kilohertz and exit. Bam. All right. 50 kilohertz looks as clean as 1 kilohertz did. Frequency, I'm quite impressed by this. I mean, that is a nice clean signal for the AC. I probably, let's see is our square wave going to look like crap? Yeah, 50 kilohertz. 50 kilohertz square wave. We have no way of neutralizing it with a probe because there is no probe. We're just going through pieces of wire as far as it's concerned. So, yeah, nothing we can do about it. If we take the frequency and drop it down to 1 kilohertz, and what's the rise time? It's looking like, what are we, 500 nanoseconds, so we're talking 500,000 nanoseconds. Yeah, okay, so 1,000 nanoseconds, 1 millisecond. Not terrible. I mean, it's good enough. I mean, at 1,000 hertz, that's good. If we take the frequency down to something you would use in my line of work, more or less, 500 hertz, that looks pretty good. Not bad at all. All right. Well, all right. So, what do I got to say here about this little guy? Overall, I'm actually kind of impressed. It appears to be a very nice little simple meter, which appears to be accurate as anything I've got. And trust me, I do a lot of repairs on stuff that's accurate as it is. The little scope is useful. It has a couple of little things that you can't do, like you can't actually look at a waveform that you've saved and expanded out. That's kind of awful. But it does what it says it'll do. It'll go up to 12 megahertz. It's not perfect, but that's not what this is. You know, this is the thing that you would put in this little bag and put into your box that you take out on site and work on stuff rather than hauling around that. I mean, this does more than this. I mean, let's face it. This was several thousand. This thing, I think they said, was $90 or $99 from Banggood, if it's out yet. Quite frankly, the way this thing works, if I'm just going out on a quick job and I want to do something, working inside of a console or fixing some piece of audio equipment that's out there behind the racks and all wedged inside of stuff, I'd rather have this than that scope meter. It's faster, it's brighter, and it works. It gives me everything I need. You can turn that oscillator, the output, on and off, and it's there if you need it. It's on a separate plug that you can get over here. So yeah, I got no complaints about it. Now the only thing we got to do now is see what's inside. We'll take a look at that next. All right, so got to figure out how to get into it. These are they part of it? No, they are not. They're not part of it. They come off. Okay. Little rubber baby buggy bumpers come off the sides. And there are 4 screws. It has a warning, remove test leads before opening case. Okay. There's your charging port right there. It's a Type C. I don't know. It looks like there was built in for other functions up here. Maybe B and C's. I don't know. Are there any plugs? No, nothing under there to unscrew. No, that's tabbed. Okay, well, let's open it up. All right, 4 screws. First of all, it has nice, most of the way around, a nice healthy insert, fire protection, that kind of stuff, so that the 2 slides slide into each other. That's the cover over the, yeah. So they slide into each other. That's a good idea. And it has the battery connector. It has an actual battery connector, not a wire or just little jumpers going down to the board. Let's take a look at that real quick. It says the battery is replaceable. And I guess it is. Okay. There's a screw here under the QC pass. Yes, there is. And wow, that's in there. Okay. So, there we go. Yes, that takes off the bail, and there's the battery. All right, so the battery is the battery. and it has a little protections built onto the side of the battery. Okay, well, it's pretty much standard for today's way of everything, I guess. Everything is, yeah. Now there's this. Okay, so will that go back on there now? Yeah. Okay. Cool. All right. Well, that's a replaceable battery, like they said. So you can't take it in too far. All right. Well, that's cool. All right. So here we go. Here's the meter. Not a whole lot on here. It says 3.7 volt lithium ion. It looks like at one time there was a way to put it there, but they put it up in the case. That's actually not a bad idea. I like that. But I do like the fact that it's honest to goodness plug. These guys, nothing to write home about. They're all right, but they're just basically round split rings that come over and solder down this other side. If something's going to break, that's going to be it. What I don't see is any fuses. Where is the fuses? Oh, there is the fuses. I don't like that. There's your fuses. You got a 750 mil and a 10 amp. Really, guys? I mean, how are you supposed to replace those? Especially if you're using the milliamp and you pull an oopsie and take out that 750, which, trust me, that happens. I mean, that's the one out of my main meter here. It's right on the front. You replace the fuse right there on the front because you're going to do it. I don't like this. I haven't looked into it. I don't know. Are these resetables? I don't think so. It says E. Fuse 1, fuse 2. And that is just a standard 10 amp fuse. And that, I believe, is just a standard. It is not resettable. That's chintzy, guys. I mean, come on. Put a real fuse in there. Does have input protection there. I don't know what's underneath here. I'm not going to take it apart. It's got a few chips. None of this really makes any difference to anybody. You know, it's not like you're going to replace them in reality. What is this? It's a APM ST 32F400. STM 32F400, which is going to be probably for the LCD or LED. Yeah, I'm not going to take it apart any farther than that. I don't really want to. So there's what's inside of it. I'm a little disappointed by the fact that it doesn't have fuses, or, you know, some sort of a sand fuse or something like that. That kind of bothers me a little bit. I mean, I know I can change the fuses, but that's not a normal thing for people to do. Oh, when you put it back together, be careful with that little guy. Oh, you're going to pinch that in there, and that probably would not be good. Okay, so how do I feel about this? Well, it's a nice little meter, and I like it. It's nice, bright numbers. It's very quick. The response time is fast. The only complaint I have about the meter itself is that when it's under the diode mode for continuity mode, the beeper's not loud enough. You just can't hear it out there. But the light does come on, and it's fixed, or it's very quick, and it's latched. So that's pretty good. I agree with that. It's good. You know, that's what you need. You need for it to come on instantly, and it does. As far as a meter goes, no complaints. It works great. The capacitance, it works well, and it's quick. As far as scope goes, it's a nice little scope. I like it. It works fast. It goes to its 12 megahertz like it says it will. Using it and then getting different scales and all that kind of stuff on it's very easy to do. Just one button for volts, one button for trigger, one button for everything else. It's just fine. It does AC and DC, which I like, and the little scope works great. The fact that you can't move it around is annoying, but it's not all that big of a deal. And the fact that you cannot expand the saved screens, that limits its usefulness a lot as far as looking at something that you saved and you want to expand that. You can't do that, but you can compare different saved waveforms. So the little scope works like it's supposed to, all the way up to its voltage, and it'll go down to, I forget, what will it go down to? I don't know if I brought this out. It'll go down to 50 millivolts. So that's pretty good. I mean, it's not 20 millivolts like a big scope, but that's fine for what you're going to use it for. Now, about the function generator. The function generator actually is quite nice. I like it. We've looked at it. We found out that it's very clean. It's a good less than 0.1%, or less than 1%. I mean, harmonic distortion, and it's easy to set up. It does square waves, sine waves, and ramp or a triangle wave. It's easy to do the different frequencies. You don't have continuously variable, but it gives you from 100 hertz to 100 kilohertz in nice steps, including 1 and 500, 1 kilohertz and 500, the ones you're going to use. And the duty cycle, most people won't use it, but it's there. It's easy to get to. And the voltages, it'll go from nothing to 3. 3 volts is nice for those of us that do audio work. 3.8 would have been nice, but that's what it is across 600 ohms. So everything on this works just fine. I like it. Great little meter, and it's light, and it does what it says it'll do. I'm going to keep it. I'm going to put it in my my bag, so when I go out into the field, and it'll get rid of 2 meters for me that I don't have to carry around. Just this one. So there you go. Gochifix 3-in-1 303 oscilloscope multimeter. And if you'd like to get a hold of one of these for your own self and a 25% off discount, there's a link below with a discount code that you have to use to go over to Amazon and pick yourself up one. There you go. Hey, thanks, guys. Till next time.